And we should be live. So hello, welcome to another one. So today is the day where we're gonna finally build our own cryptocurrency. Yeah, so I have some, so this is gonna be like loosely follow up on the previous playlist that I've done, which is mostly about me learning about like smart contracts and cryptocurrencies and how they work. Oh, now I realized you don't need to see the code at this point. Yes. But so now we're gonna loosely follow that up with doing some more stuff, and the more stuff is creating our own cryptocurrency and trying to figure out what is it for and how does that work. Yeah, so it's hopefully it's gonna be fun. And as always, the point of this is for me to learn stuff because I barely know what I'm doing most of my life. So let's start with this. You basically have two options, maybe more, probably more, if you want to start your own cryptocurrency. One would be to create your own, blockchain stuff. So you would go with you would create when there was Bitcoin, some people came up with Ethereum and they created Ethereum, which is kind of difficult because that has drawbacks to it. But you have a freedom to do whatever you want in your protocol in that case. Another option, which is kind of easier, and which I kind of failed to keep it secret because you already saw the screen and it's at Erc20, which is that's the name of a kind of API, let's call it, of a tokens that you can build on top of Ethereum. So you would use a smart contract to code these tokens, and you would create the tokens that way. Like when you go with this path, there are several advantages to it. Like first, as we're gonna see, it's super easy. Like you can do that within a few hours of work. Second, you kind of inherit the whole ecosystem of Ethereum, so you don't need to convince people to mine your new cryptocurrency to process transactions. So if you want to send some of your new coin to somebody else, you need somebody to actually do the change in the state of that blockchain and propagate it. So, and because we're running on Ethereum in this case, you've already have all that infrastructure sorted out. Yeah. Another advantage, like when you would start your own cryptocurrency, like in most cases it wouldn't be the decentralized. Like although the aspiration might be to be decentralized cryptocurrency, at the beginning you will just be mining on your machines. So that's kind of centralized. But I guess you would incentivize people to join your network, and then you would have more nodes, more miners around doing stuff for you. So that's kind of fun. Yeah, but there's one big disadvantage of doing it. Well, there are a few. The biggest one is the fees, I guess. Currently the fees of Ethereum are kind of restrictively high. I think it's around $40 for transaction. Like it varies, right? The way how that works is you kind of on each transaction you say how much gas you're willing to pay. Gas is this meta cryptocurrency used by Ethereum where you like kind of price the transactions, and then the miners will choose the highest payer and do that. So the current amount is around $40. So that means that for every transaction on your cryptocurrency that you're going to build on top of that, you also need to think about that. So whenever somebody would like to send your new cryptocurrency to somebody else, they will need to pay the same fee for the Ethereum transaction because that's how that works. Yeah. Another disadvantage here is that it's not going to be native. So what I mean by that is that Ethereum has this Ether as a native currency that you can like move around. and all transactions and all states are kind of built around that Ether. But if you build your own cryptocurrency on top of it, the transactions are not, when you transact stuff and when you store the state, it's only stored within your own contract, within your smart contract, not in the whole ecosystem of Ethereum. I guess that's kind of harder to explain, but that, yeah, you kind of limit it in that way. So why would you do that? So let's talk about some examples. Let me switch to this thing now. So one example of let's see, Etherscan, and I'm going to talk about one example that is built on top of Ethereum, and it's kind of popular cryptocurrency, and that one is Mana, or Decentral, yeah, this one, Decentraland. So Decentraland is kind of metaverse, decentralized project where you, you know, it's not too important, but you have like your avatar, you move around, you buy stuff, and in-game currency is this Mana, which is ERC20 token. So if we look at the contract here, which is the smart contract they've written, like folks and decentralized, we can see that the contract is here, and here we actually see the source. And the important part that I wanted to show is, I guess it's here. No, this is just an interface, not important. Here. So here's where all the balances live. So all the mappings, like this account has that many of the Mana token in this case, lives in this state of that specific smart contract. So it's nowhere else, right? Like this smart contract is obviously living on a decentralized state, so it's not just one copy, but it's not native to this thing. So then, how do you would like do the transfers? How would you like do the marketplace if it's just your private or your own smart contract that holds the state? Because if we look like in Coinbase, I guess, let's see. I guess we should be. Ooh, that's not good. Or is it something else? Coin. Ah, okay. Might have been. No. Okay. I think it's my proxy settings. Let me try to sort it out. Sorry about that. Oops. I lost a lot of stuff. It's right here. I'm trying a different browser. But it might be the same problem. Okay. Well, actually, sorry about that. Again. I guess maybe I could do this. No, still doesn't work. Am I using the wrong URL by chance? Well, anyway, I guess on Coinbase, Mana, maybe there's something here. You would see yeah, I guess it's gonna be the same problem. It's just my setup, I think. So you would see the Coinbase, you can actually trade it there, you can do stuff there. But how come you can on Coinbase, and same for Binance or some other providers, how come you can, you know, trade it if it's just their own internal, you know, it's just a smart contract that keeps this? Well, one way they could do it is that they would, like in Coinbase, they would kind of look at this contract, figure out how to like interact with it and build integration for it. But that obviously doesn't scale that well, because if you have more currencies you would need to do that again and again and again. So what you can do elsewhere or differently is that you would, yeah, have a standardized interface. And that's exactly what Erc20 is. It's like interface, it kind of describes what methods the smart contract has. And then whoever is interacting with this contract doesn't need to have the actual implementation of that contract, actual details of that contract, because they know they can use the interface to interact with it. So there's like a transfer method, for example, to like move tokens from one address to another one, and they all have to have them if they implement this. There still needs to be some sign-up flow, I guess, in Coinbase and such, where you actually send them, so this is my address of my contract, and then I guess there's some legal stuff, I don't know, but I guess the address of the contract is all they actually need if you tell them that it's ERC20 token. So that's kind of cool. One thing I wanted to mention as well is, why is it called ERC20? So there are two terms, they're kind of similar. I've written one, the other one. Oh, let me check my notes if I haven't forgot anything. I don't think so. So there's ERC and EIP. So ERC versus EIP. Those are very similar terms. Both are like kind of, well, one is, EIP is Ethereum Improvement Proposal, and ERC is Request for Comments or something, Ethereum Request for Comments. So it's like kind of standards of the core Ethereum stuff. But let's look at another thing, which is, another question, good question would be, why is it 20? So that's kind of, I'm trying to find a link. No, that's, it's just because it's like open source, so it's, the source code for Ethereum lives on GitHub, and then somebody opened an issue, and when you open an issue you get an ID, and when they open this token standardization issue, maybe we can still find it, it just got an assigned ID of 20, and then it, here, and then it just, that's the ID it kept. So this was like new issue, it got ID of 20, and so that's why it's ERC20. And then similarly there's 721, which is for non-fungible tokens, so that's the NFTs. The fungible, the ERC20, is like cryptocurrencies, like you don't care, you can't tell one token from the other, doesn't matter, you can trade them, they have still the same value. On ERC721, which is the NFTs, you can't do that, right? You have a Picasso image and what I've drawn, and it's a completely different value, so you can't trade them. Yes, so that's that. Alright, so now we're kinda running out of the boring stuff, I hope. And I'm now gonna try to, implement it, so basically. So this is pretty empty a project here that has just readme, license, and getting an R in it. I've done some videos previously where I talked about like how to set up with Truffle the project, so I'm not gonna go over that too much, but a little bit. So basically we're gonna do Truffle in it here. Boom. So this worked, and now we have contracts, migrations, test. So this migrations contract is a contract you always get when you do Truffle init, and it kind of keeps track of which migrations you've deployed, so it knows which it should do next. But that's not really important for us at this point. We can create a new contract here, and it's called BeaverCoin Sol. So why I'm calling it BeaverCoin is because the name of the channel, I think, somewhere, is Beaver Codes, so this is gonna BeaverCoin. It's kinda, stupid. Anyways, So what would you do? You would do BeaverCoin, boom. Oh yeah, we have to have this pragma at the beginning. Whatever. So I think 8 for reasonable amount. So basically what this says is which Solidity compiler we need to compile this code. Depending on the version of like features you use, that's what Solidity compiler you need. But you know, 8.4 is fairly recent, I think, so it's probably fine. So yeah, so now we have our contract. Before we do that, let's have a look at one more thing. Let's have a look at this. So Erc20 Interface. Interface. Boom. So as I said, it's an interface. So that means that somewhere are defined functions that we need to implement. I think there's a... I saw before. Alright, let's do one more thing. So another way you can name it is if you just put I in front of it. That means that you want the actual interface. And here's one from OpenZeppelin. We're gonna get back to the OpenZeppelin later. But basically this is the interface. And this is a Solidity code as well, as you can see. So we can just copy this. Oops. Oops. Like in real world you wouldn't actually copy it, you would import it, which we're gonna see in a second. But for the first part I figured it would be fun to actually try to implement it. So there's a bunch of methods. Let's focus on the... I'm gonna delete these. Like if you would be implementing the interface fully, you would have to implement all of those. But for now, let's just get rid of it. Let's get rid of the comments so it's more readable here. Boom, 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 boom. So the core functions for the ERC token are these three: total supply, balance of transfer. They kind of self-explanatory. Total supply means how much tokens do you have in total in your market. Balance of is the balance of specific address, how much token does this address have, and transfer is I want to move tokens from my balance to this recipient, and I want to move that amount of stuff. I'm just gonna source file requires different compiler version. Current compiler is okay. Okay, well that's fine. Let's do this. No. Okay, I think it's because, here in Truffle config there's somewhere like a compiler. No? Oh yeah, it's 084, not 084. Okay, so we're just gonna fix it. This should be fine. Yeah, this looks good, right? So now we could start implementing it. The first and the most core data structure, I guess, you wanna is that mapping that we saw in that mana smart contract. And as we saw there was just like a mapping of an address to UNT256, and we can call it balances, and we can make it private. So in this case it just doesn't matter too much if it's like private or public, but it does actually matter, right? Yeah, I think by default they are like read. You are able to read them, but you're not able to change them, which would work fine in our case, but it's better to be more restrictive than less. So that's nice. So if we want to implement an interface, we would do is ERC20, like so. And now it already complains because, you know, we haven't implemented all these methods. So it's saying contract should be abstract. Because you haven't implemented all the methods, you cannot create an instance of it so that it fulfills this interface. Yeah, so we need to implement those methods, basically. So total supply, let's start with that. Yeah. Now let's maybe comment out these two from the interface, so then we are happy with just implementing this first one. So how would you return the total supply? I guess one way of doing it would be just iterating over the mapping and collecting all these values, right? So if user A has 5 token and user B has 10 token, then total supply should return 15, right? So that would be one way of doing it. The problem is then on every, that's kind of expensive, a little bit, to iterate over it, and then also mapping itself, the data structure, doesn't have the concept of iteration in Solidity. So you would have to kind of keep the key somewhere else. So you would have, I guess, something like address, boom, array, and this would be owners. And whenever you would transfer stuff to some new owner, you would add that key to this list. But you need to deal with the fact that some of them might already be there, so this is kind of messy. So one easier way to do that is you just keep the balance as a separate field. So you can do total supply. Boom. So notice, by the way, that I'm putting these underscores on the private. That's usually no matter what programming language you use. Usually when you put underscore, that means private, or don't use those functions or fields in this case. But it also so that it doesn't conflict with the exposed methods here, because that's the same name of that item in the class or contract in this case. So it would conflict and it would not be happy. If I would remove this, I think, yeah, I'm gonna get squiggly lines that this is not acceptable. Yeah. So I guess the total supply would be then just, let's return total supply. Boom. And it should, I guess, work. You know what? What I like to do when I'm coding and failing to code is to have kind of a quick feedback loop, which is kind of useful. So that means in this state I would go and deploy it so that I can see it. So that's exactly what we're going to do next. One cool tool you can use is Ganache. Ganache has a UI. I'm putting the ampersand so it starts in a daemon, so it doesn't block my terminal here, but that's just, I don't need to do that actually, so let me do this. I can get a new terminal, those are for free. So now it's this starting. I'm going to get rid of that, that's from some previous tests. What you can do here is you can say new workspace, boom, and then whatever, BeaverCoin, that doesn't matter. Yeah, and save workspace. So let me put this side by side now for a second. And now, this Ganache UI is just happily running in this terminal. Now we need to configure our Truffle config to use this local Ganache. So what Ganache does is that it creates its own blockchain, that it runs it on your laptop locally. So it has just one node, it's not decentralized at all. But the benefit is it kind of all the transactions happen instantly, so you don't need to wait for anything, and also you don't need to pay for anything. So it's awesome for development. And all these addresses, you at the beginning when you start Ganache, it will create 10 accounts for you to play with and to do stuff with. So these are all 10 addresses, and they start with 100 Ethereum each. Yes. And then if we go back to the Truffle config here, there's somewhere here. There's a section where you configure where you want to connect to. Where's the running, I think it's called Erc Client, which is a client that is connected to the blockchain and can talk to blockchain that you want to talk to. It can be local or can be somewhere remote, like on the internet. So it's mostly fine, but we can see that port here is 7545, so we're gonna change that here as well. So that's kind of cool. Right now we can already run, I guess, Truffle and then deploy, maybe. So because we changed this to development, it connected correctly to this blockchain, and you see that the balance of the first account, which is by the way what all the default transactions and operations will use. If you don't specify account, it's just going to use the 01 or the first one. So you saw that it decreased because when we look at transactions, there actually was some activity here. When we look at, okay, this wasn't, okay. At projects, you point it to your Truffle config, this Ganache UI, and then I guess save and restart. And then you can look at the contracts that you have in your system. And it says that this one, migration, was deployed, but our BeaverCoin wasn't. And also the interface wasn't. So that's fine. But how do we make it so that it is deployed? And the answer is we need to look at, when we created this Truffle project, we had migrations folder that I haven't mentioned. And it has, those are a bunch of JavaScript scripts that will be ran to kind of deploy the stuff. They are very simple, as you can see. They do very little, but they can vary in complexity, of course. And then this migration, as I mentioned, it kind of keeps track of which migrations you ran already. So when I run deploy now, it's not gonna deploy this migrations contract again, because it knows that was already, everything's up to date. I'm not doing anything. So we can create a new migration. Boom. And let's call it BeaverCoin migration. And then serve 2. So the numbers at the beginning, why they are important, is that basically when Truffle runs the migrations, it will go one by one in alphabetic order, I think. And then it stores, when we look at here, last compile migration. I guess it competes some sort of hash or something of the name. And then it knows that it ran like migration number 1, but it didn't run migration number 2, so it's gonna run migration number 2. So it dictates the order in which the migrations are ran. So in our case, we wanna change this a little bit. I guess I had capital C here as well, and then I'm gonna rename this. And that's all we really need for this exercise. So we're gonna deploy BeaverCoin. And that's it. Cool, let's try again. Perfect, so it tells us I'm deploying BeaverCoin. And if we look back at here, we see that this one is now deployed. And we can look at, has the balances and it has total supply. Okay, one more cool thing we can do, arguably cool, is if you would, you can do Truffle console here, boom, hopefully, yes, and now you can do a bunch of cool stuff here, including you can do the deploy command from here, which we're gonna do later, I think. But let's do this first. So we want to grab an instance of our smart contract deployed on the blockchain. So to do that, we would do BeaverCoin. So notice that the name is already here, just by the magic of Truffle. Yeah, I mean, I don't know the internals, but when you build and compile, you build this BeaverCoin JSON, which is the API of your contract here, and it also probably parses this, so it kind of works. And there is a method deployed, which will fetch the latest deployed contract. So if we do contract header and address, this is the address of the contract, and if we look at the contract here, the address is 0CA at the end, which is 0CA here as well. So it's the same contract, so that's good. This is a good thing to check, because when I was like preparing, I make many mistakes where they just didn't match. So I was changing something and it just didn't happen here. But it's fine. So now we can do contract, and notice that I can press tabulator and it like helps me, completes what I'm typing. So I can do total supply, right? That's the function. It returns a big number, so it doesn't look good, but anyways, it's 0, which is correct, right? Because there's no tokens yet. So that's nice. Now if we look at here some more, so let's say we would like to create some tokens. So to do that, you would do like, let's call it mint, and then 256. So by the way, uint is unsigned integer, 256 is the size in the memory, and 256 is the default size in bits of the memory used by Ethereum Virtual Machine, EVM, which actually runs this code of yours. So these are like the biggest numbers you can put there natively. Yeah, I guess. And then amount. Yes, and then we call it external, because we can call it from outside. I guess only, in our case, that's fine. And then what does mint gonna do? It's gonna look at balances, and then it's gonna send message sender. It's gonna increase the balance by that amount, and then also it's gonna increase the total supply. Right? That kind of makes sense. Now here in the console, down there here, sorry, that goes too fast maybe, here, we can run deploy command. So that's the same thing as if we ran before Truffle deploy. Notice that it didn't actually deploy anything. Yeah, because that's how these migrations that I mentioned work. But if you still want to force it, you can do reset, and then it's just going to deploy new contracts. So that's what we're going to do. So now we deploy the new contract. You can see that the new contract address is this 3BF. I don't know if it updates here. It should. Maybe it doesn't. I guess it doesn't. Maybe we would have to like restart this. No, I don't know. Well, we don't need this UI anymore too much, to be honest. So let's just look at this. So that's kind of cool. We can do this one again. Oh, before we do that, if we do contract address, so that's the old one, right? That's the one before we deployed one. Oh yeah. But now we're gonna fetch a new one, hopefully, and this address should be different. Yes. So this is the old one, and this is the new one. And if we look December at the end, yeah, that's the new one that we got. So that's kind of cool. So we can do contract dot total supply as before. This returns 0, but we can also do mint. And let's say 20. So we get the transaction confirmation here. And if we do total supply now, it's 20. So that's perfect. So that worked. Now we also put it in balances, but we don't have any way to like check balances, which is where the second function comes in. So let's do that. So let's implement this one. And it will be super simple. It's just balances of account. And we can do that. So as you can see, the implementation of this interface doesn't have to be complicated, but it can. That's the benefit of smart contracts. Like you can add extra layers of protection and stuff like that, which is a good thing that we're going to talk in a second, I think. So now we can deploy it. We should not forget to like refetch the new contract, because that's the one thing that I haven't explicitly mentioned. It's that all the smart contracts, all the blockchain, it's very immutable. So when you deploy a smart contract, you cannot change it afterwards. Here it's fine in our development process because we can just deploy the new one and then use the new one instead. But imagine that you would be in production and you would deploy this smart contract and you would like to do an update, and let's say Coinbase has a link to the old one, or like people are sending their Ethereum to the old one. So that's very tricky. There are some patterns you can use that you would have like a one smart contract which would be the main one, and it would just delegate calls to the other one, to the other one, and then there would be like an address and in a field. Like here you would have like another field which would be address, and you as owner you could change the address, but that's, yeah, it's kind of tricky. Anyways, so now if we do that again, let's mint some more, and then we can do contract balance of accounts 0. Boom. So now you can see that that contract has actually a balance of something. We can build another 15 maybe. And if you look at that, it's 35. And then also total supply, right? That's 2 weeks. Yes. What we haven't talked about, and I realized, is this accounts variable. And it holds those 10 accounts that we talked about the Ganache creates at the beginning. So that's that. So that's why when I used account 0, it just referenced to this address. But there's one big security hole that we introduced. Like, you can, so this second argument or second option to any method call here is like some options that you can send in. One of the options is from which account are you sending it. So if we do accounts 1, this actually worked, right? So if we do total supply, now we have 50, and if we look at balance of account 0, we have 35, accounts 1 has 50. So that's the problem, right? or feature, depends on how you phrase it. But in this case we just created a cryptocurrency that anybody can create tokens for themselves, which is in most cases not what you want. So we need to gatekeep that in some way. So basically what we want to do is just say, this is only for me to call. How do we do that is that we need to come somewhere store the person creating the account, the instance of the contract, and then reuse it. So we can, what we would do is we can do address, private, and that's the owner. Owner of this smart contract, not of the tokens, but the smart contract itself, the instance of that smart contract. Okay, so then next one is, how do we like set this owner? Well, there's a constructor that you can build. Boom. For Ethereum smart contracts that runs just when it's being created. And then it's very simple, we're just gonna do owner equals message sender. I haven't actually talked about this, but the message is a global variable that gets injected into your smart contract during a transaction execution. And it has a bunch of useful fields. One of them is sender. It has also message value, which is amount of way, which is the smallest denominator, such big words today, of Ether, the cryptocurrency. Yeah. But we don't need that, we just need sender. So we're gonna set that as owner. And by the way, this can be both like somebody's wallet, like somebody who's calling the action, somebody's account, or it can be a smart contract. If the smart contract is calling another smart contract, which is a perfectly valid thing that can happen. And in a lot of like the security breaches or like hacks, it's actually done by smart contract calling this contract or some contract and breaking it that way. But it's a topic for other time, I guess. Well, now we want to validate somewhere, so we can see require, which is a validation method, I guess, call, to check stuff. And we basically just want to say that the owner is message sender in this case. So whoever is calling this transaction, mint, needs to be the owner. There's a second parameter you can do, which is like a text that's going to be returned. That's going to be returned if it fails. So we can do that. And then again, we can deploy this guy. Perfect. And then we can grab the newly deployed contract. Boom. Which is good. And then we can, try to mint from account 1. And it fails with exception, that this is just for me to call. But if we call it with the proper account 0 that created that smart contract, it's just gonna work. So that's nice. That makes sense, right? I think. Yes. Okay. Yes. There's a little bit of problem still, I guess. What if we would... what I was about to say is, what if we would mint it with minus... whatever. 150. So in this case I guess it fails because value out of bounds, because we have unassigned integer. But what I was trying to get to is that there is this overflow or underflow issue that you should be aware of. Let's say we have binary mathematics is over my head right now, but let's say we would have some small one like uint 4, rate. 8 bits can hold only some big number, like small number actually. 256, I don't know. I should know that kind of stuff. Anyways, so let's say it can hold 256 is the maximum value, which is probably wrong, that it can hold. What would happen if you already have 200 and then you try to put another 200, which is, 400, which is way bigger than 256, right? So it's just going to wrap around that thing. So it's just going to be like, it will result actually in 400 minus 256, which is some number. And that's going to be the final result in there. So that's kind of tricky. Like, Win256 is way bigger, so it's usually not a problem, but you still need to be aware of this and use some sort of mitigation in that case. So there's some math libraries that are built for this, where they can do the validations before and after and make sure that there is no overflow, underflow. Okay, that's what I wanted to mention as well. Alright, let's look at the last one from here. Transfer. Boom. And transfer, again, should be very easy. We're just going to do balances. And then recipient. Just gets plus that amount, right, that you're sending, and then the sender gets minus that amount. Oh, and you're supposed to return true if all is fine. So let's do that. Ooh, something went dark here. So that's nice. So I guess if we deploy again, and this is the last one I'm gonna do, I promise. We're not gonna do those more advanced, but then I'm gonna talk more about the Open Zeppelin, which is super useful. Yup. So we can do, contract, mint, whatever, 20. And then you can do transfer. What's the next one? It's the recipient, so we're gonna say let's transfer to accounts 1, 10 of them. Boom. Yeah, and then we can do total supply. Should be still 20, right? Still 20, and then balance off. Accounts 0 is 10, and accounts 1 has 10. Again, we didn't do any validations, so if we would do transfer 100, that's gonna fail. Okay, that's good. Oh, that's good to know. Alright, it failed because we're doing this line, and if you do 10 minus 100, it's not going to be unsigned integer anymore. I'm assuming that's why. It doesn't tell me, but I would expect that's why. It doesn't. No, it's not saying it. But it's probably that. And then what happens is that it reverts, which is kind of interesting or important to understand as well. Whenever there's an exception thrown, like require, even if you've already changed some state before, all that is happening within a transaction. So that means you can think of it as like database transaction. It either gets committed at the end and all the changes happen, so there are this is an attribute called atomic of transaction. They all happens or none of that happens. So although this line was fine, right, that would work, 10 plus 100 is 110, that's fine, but then this one failed, and it reverted the whole transaction. So if we look at balance of account 1, it's still 10, well, both of them are still 10, so none of the operations actually happen on a blockchain. Yep. You still need probably more validations here. So. Yes, I'm gonna drink a bit of tea. And next I'm gonna tell you that this is horrible code. You probably already knew that, but the reason why is that it's not good code is because there's many things that we haven't thought of, haven't implemented of validations of different sorts, and because it's such a delicate, I guess, thing, smart contract on the smart chain. You need to be super careful because money is at stake, and it's actually deployed to smart contracts, smart chain like the blockchain, so it's not easily changeable as we talked about before. So you want to make sure that you're right in the first time. One thing you absolutely should do is write the unit tests around this, what Truffle helps you to do as well. But another thing you can do, which is like I guess recommended way of implementing Erc20 tokens, is use existing implementations. So let's look at that. And so one of the biggest players, I guess, or like again, it's all open source, it's all decentralized, but it's this Open Zeppelin, where we took this contract from. They not only have the interface, they also have the actual implementation, where you don't need to like implement all that we just done. You would just use their thing. So let's look at how to do that. Hopefully we will not run in that proxy issue. Okay, this looks promising. Yes. Contracts. Looks good. So this is kind of a nice tool. What you want to do is do this. So you want to have no dependency, which is opens up contracts. Back in our contract. Let's get rid of this for now. You do that. Okay. So we can do npm init here. So it's just that we get the package JSON file here. Yes, sure. And then we run this npm install contract. So what does that do is, when we ran an init, it created these files, we populated with some stuff, and then we added one dependency, which is this open contract, and it downloaded it here. So that's kind of neat. And now what we can do is we can, let me just grab that because the path is kind of long. You can just grab this. So you're saying, please import this, whatever's in this file. And that actually imports the whole implementation, not the interface. So we're gonna say Erc20 here. And right away we have a bunch of squiggly lines around. We have a bunch of squiggly lines, like, do not do this. Because they've already done it, so you don't need to do this, or you shouldn't do that. It's no longer an abstract method you can overwrite. So you can get rid of that. Yes. It should be marked as abstract, right? Oh yeah, it's because of the constructor, right? No, it doesn't tell you here, but I think if we do Truffle compile, it will warn you about the constructor. Right? It tells you here, missing implementation of a constructor with memory and so on. And this constructor comes, I'm going to show you magic now. I'm pressing Ctrl on my keyboard and clicking this link. And VS Code will take me here. You could also, you go known modules, follow the path. Follow this path of where it's actually located, this file. You can click it and it will take you. it's not that big magic, I guess. And you can see the actual implementation, and you can see the constructor has two arguments that you need to send in. You can also look at some of the implementations. Like this was exactly how we do it. There's nothing like easier to do. But you can look at other implementation of stuff, like the transfer method to actually transfer stuff. There's a lot of more validations and stuff like that that are good, that we haven't thought of, right? So that we get for free. Now the constructor, so you do it here, and it wants name of the cryptocurrency. How do we call it? BeaverCoin, I guess. And then the actual Bitcoin. Bitcoin, that's a good name. So now it's happy, I think. So now we don't need total balances because that's all internal. We still want to be able to mint, right? But we're no longer using our balances. It's using their balances, like what was inside this contract. So how would we do that is that we would call this method mint, and we're gonna say message sender, and then amount is amount. That's correct. So we can look at what this function does. So now we're back in their implementation that we fetched, imported, and it does pretty much similar thing that what we've done, but adds some more validations, emits some events that we haven't talked about, stuff like that. Anyways, now we should be pretty good. So if we do Truffle console again, BeaverCoin, what? Horrible. Oh yeah, Truffle console. Now we can do deploy, reset, boom. And if we do that again, let contract equals bcoin deployed, boom, and we need to await that because it's a sync call. Now we can see that we can still do like total supply, probably, and we can still do mint, 300. Now works fine, and then total supply works, and all those things. But we can also do all the other functions that we haven't implemented above, like or before, like this allowance that we haven't talked about. You can call that now. Yeah, okay. You need to send some stuff, but yeah. So now this is the end contract that you have. They also have extensions for like mintable, so you wouldn't have to even implement this part yourself. I looked at that extension. It looked more complicated than what I was needing here, so that's why I kept my code here. But yeah, that's that. So that's kind of cool, I think. There was something else I wanted to say, but I forgot already. Oh yeah, what's that approval and allowance stuff for? So you could do this, you can like transfer tokens, right? But because normally what you want to do is like exchange it for something, right? You want that person to send you Ether, and then they're gonna buy the token from you. So that this happens in one transaction, you need to kind of delegate that functionality to somebody else. Or you could do it here, but you would like increase your token. So what you could do is you would say, I'm giving like 40 of my tokens, ability to move 40 of my tokens to this address. And this address would be some smart contract that would kind of figure out this matchmaking and when the person sends their Ether in, the smart contract would transfer your tokens of BeaverCoin to that person. So that's what it's for. That's what it's for. Yeah, I guess that's it. Unless there's no questions, and I think there are no. I'm gonna take this thing, put it, yeah, push it to the repo, and then it's gonna be awesome. Alright, so have a wonderful day, and I'm gonna cut it here. Bye.